In this video, we will be looking at derivatives. So derivatives are the rate of change for the parent function, and derivatives are found from the parent function itself. So derivatives show the instantaneous rate of change for the parent function. So we can look at the graph on the right side. So as you can see, the red function is the parent function, or f of x, and the blue function is the derivative of f of x. So as you can see, the parent function is a quadratic and the derivative is a linear function. So when looking at a graph of the derivative alongside the parent function or a derivative by itself, you look for certain things. So one point in which you may look for is intercepts of the x-axis. So whenever the derivative of a function is at an x-intercept, that means that the parent function is either at a local minimum or local maximum. So in this graph, you can see that the derivative, or the blue line, intersects the x-axis at the origin. And you can see at the same point, the parent function is also at a local minimum. Another thing you might look for is, as the derivative denotes the instantaneous rate of change, when the derivative is negative, that means that the parent function is decreasing. And when the derivative is positive, that means that the parent function is increasing. So if we look at the green lines, so if we look at the point in the function where x is equal to a, we look at the instantaneous rate of change for the parent function. So with the derivative, which is a function by itself, you can input the x coordinate values of any point in the parent function, and by solving for the derivative, it will give you the instantaneous rate of change. So if we look at x is equal to a, if we trace down to where the value of the derivative is at x is equal to a, we can see that it is b, which must be noted as a negative value. So therefore, the instantaneous rate of change at point a for the parent function, or f of x, would be equal to b. There are many ways to find derivatives, and there are different ways you find it depending on the type of function you're dealing with. So the first type of function which we will be looking at is the basic one. So if f of x is equal to x to the power of n, then that would mean that f prime of x, or the derivative, would be equal to nx to the power of n minus 1. So you can see that first we bring down the exponent of the variable and turn it into a coefficient, or multiply the coefficient by it, and then you subtract 1 from the exponent itself. This is pretty simple, and we can look at an example of this. So for example, in the question, to find the derivative of f of x when f of x is equal to 3x squared plus 2x plus 3. So in order to find f prime of x, we need to use the formula we just discussed. So looking at firstly the 3x squared. So first we bring down the exponent, so it would be 2 times 3, and then we would have the x, and then 2 minus 1. So that is what you do for the first term. For the second term, we do the same process. So x is obviously to the power of 1 for the 2x, and this would simply leave us with just 1 times 2 for the coefficient. So then it would be x to the power of 1 minus 1, which is 0. For a constant such as 3, it is negated for finding the derivative, so you don't even include it. So looking at the final answer, the f prime of x of this function would be equal to 6x plus 2. So this is pretty simple, and pretty understandable. But functions will not always have terms and variables being added or subtracted. So when terms are being multiplied and divided, there's a different method which you use. So this can be seen first looking at multiplication. So if f of x is equal to x times y. So imagine x and y are two different functions. Or actually we can use u instead of y. That makes more sense. X times u. So in this case, then f prime of x would be equal to x prime times u plus u prime times x. So you take the derivative of each of the terms and multiply it by the normal function for each. And this is a bit more complicated, so we will be looking at an example. So the example we'll be using is if f of x is equal to 3 minus x squared times x plus 4, how would we find the derivative? So this is clear that there are two functions in this. The two functions are, of course, the 3 minus x squared and the x plus 4. So those will be our x or u values per se. And so in this case, f prime of x would be equal to, so firstly, taking the derivative of 3 minus x squared, which 3 you negate as we figured out before. You bring down the 2 and on the x squared and subtract 1 from the exponent. So that would be minus 2x times the normal function for the other one, which is x plus 4. And then you add the derivative of x plus 4, which would simply be 1, as you negate the 4 and you bring down the 1 from the exponent from x, and then subtract 1 minus the exponent, which would just leave x to the power of 0. So it'll be 1 times, and then the normal function for the x value per se, so 3 minus x squared. Simplifying this, we are left with minus 2x squared minus 8x plus 3 minus x squared. So to further simplify, we can take the two x squared terms, with minus 3x squared minus 8x plus 3. So that's what the derivative would be for this example. So functions in which a function is being divided by another function works in a similar nature, but is slightly different. So looking at this, so if f of x is equal to x over u, so a function divided by another function, then that would mean that f prime of x would be equal to x primed times u minus y prime, or u primed, times x divided by u squared. So that is the general equation which you would use. And to make it a bit more understandable, we'll be looking at an example. So if f of x is equal to 5x plus 1 divided by 3x minus 4, then what would f prime of x be? So the two functions which we can clearly identify are the 5x plus 1 and the 3x minus 4. So in this case, so we would start off with the top of, or the numerator. So we can start off with 5x plus 1 primed times 3x minus 4 minus 3x minus 4 primed times 5x plus 1. And this all would be divided by 3x minus 4 squared. So now we must find the actual primed values. So for 5x plus 1, the derivative of that would simply be 5. So it would leave us with 5 times 3x minus 4 minus, and then the derivative of 3x minus 4 would simply be 3. So 3 times 5x plus 1. And again, this all would be divided by 3x minus 4 squared. So now to further simplify this, we can move on to simplifying the numerator. We will keep the denominator the same throughout, just to keep it simple. So that would leave us with 15x minus 20 minus 15x plus 3. And again, all of this divided by 3x minus 4 squared. So finally, the 15x's will cancel out, and it would leave us with negative 23 divided by 3x minus 4 squared. So that would be the final derivative of that function. Next, we will be looking at trig functions. Trig functions are actually very simple if you look at it, so we can do them all here. So if f of x is equal to sine x, then f prime of x will be equal to cos x. And if f of x is equal to cos x, then f prime of x is equal to minus or negative sine x. And finally, if f of x is equal to tan x, then f prime of x will be equal to 1 over cos squared x, or secant squared x. So these are all very simple. It is just memorization. If there's a coefficient in front of the trig term, then it is not really included. So for example, if you find the derivative of 3 sine x, that would simply be 3 cos x. And yeah, that is pretty simple. There is slight complications which we will discuss later on in a different aspect of derivatives. So next off, we'll be looking at long functions. So for a long function, if f of x is equal to ln, that was not good writing, ln x, then f prime of x will be equal to x primed divided by x. So also, if you're finding the derivative of just ln x, it will be 1 over x. So an example of this would be if f of x is equal to ln 3x squared plus 2, then what would f prime of x be? So f prime of x would be equal to, so of course it is x primed divided by x. So to find the primed, so the numerator would be the prime. So you find the prime of 3x squared plus 2. So 2 is neglected because it is a constant. So first we bring down the exponent. 2 times 3 and x to the power of 2 minus 1. And this is all, of course, divided by 3x squared plus 2. F prime of x, to simplify, would be 6x divided by 3x squared plus 2. And it's possible to simplify further, but that is really all you need to know. Another thing you might hear often with ln functions is if f of x is equal to ln x, then f prime of x is equal to 1 over x, which holds true, but in certain situations it can be more difficult. Another thing that you can note is if a function is stated in a way where it is like f of x is equal to ln x to the power of 3, then you can bring the 3 to be a coefficient of it. So then f of x would be just simply 3 ln x. And that can make it more simple at times. And of course, the 3 is not included when you derive the ln function itself. You simply put it to the side and add it to the result. So next we will be looking at exponential functions. So exponential functions are a bit trickier, or they're not bad, but so if f of x is equal to u to the power of x, then f prime of x would be equal to 3 to the power of x. Sorry, that is the wrong example. It would be simply u to the power of x, so just a normal parent function, times x prime, so the exponent primed, times ln of the base, so ln u. And that is really all it is. So for an example, so if f of x is equal to 3x, then f prime of x would be 3x, so just the normal parent function, times the derivative of the exponent, which is x primed, times ln the base, which is ln 3. And of course, from before, we know that x prime is equal to 1. So 3x times ln 3, because we'll just ignore the times 1. And that is really all you need to know. And yeah, that is how you solve or derive or find the derivative of a exponential function. And next we'll be looking at Euler's number, or E, which is very similar to a exponential function. So Euler's number will use the same rules. So in simple, if f of x is equal to e to the power of x, then f prime of x would be e to the power of x times x prime times ln the base, which is ln e. But what you need to know is that ln e is always equal to 1. So you really don't need to include this because it's just multiplying the whole thing by 1. So the equation which you will actually use is e to the power of x times x prime. And that is the derivative of Euler's number. So it's very similar, but you simply remove the ln part because ln e will always be equal to 1. So for an example, if f of x is equal to e to the power of 4x minus 3, then f prime of x, what would it be? So firstly, we just take the normal parent function, so e to the power of 4x minus 3, and then we multiply it by the derivative of the exponent. So derivative of 4x minus 3, the 3 is negated, and the derivative of 4x is, of course, simply 4. So, and you can rewrite this to be f prime of x is equal to 4e to the power of 4x minus 3. And that is what the answer will be. So finally, we will be looking at inner functions. So oftentimes in a function, there can be another function within it. So these must be considered. And so in these situations, you have to sort of separate the inner function and the outer function. So when this occurs, the outer function is derived separately and then multiplied by the derivative of the inner function. So this might be a bit complicated to understand verbally. So to give an example is going back to the trig. As I said before, there are complications in it. So if f, that is terrible handwriting, if f of x is equal to cos 3x cubed, how would you find the derivative of that? So the derivative, which would be f prime of x, so the inner function, so we must identify the inner and outer function. So the outer function would simply, we'd be looking at cos times x. So we just sort of ignore the 3x cubed and just the outer function would simply be cos x. The inner function would be the 3x cubed. And yeah, that is how you approach it. So deriving the outer function, which I will write in blue, would simply be essentially deriving cos x, which we know to be negative sine x. And so we write that as negative sine, and we'll just keep the 3x cubed. And we don't do anything with the inner function for when you're deriving the outer function. And now for the second part, where you derive the inner function and multiply it. So then this would be times, and the derivation of 3x cubed. So you bring down the 3 and multiply it by the coefficient and then subtract 1 from the exponent. So that would leave us with 9x squared. So 9x squared. So that is really all it is. F prime of x would be equal to negative sine 3x cubed times 9x squared. And that is how you work with inner functions. And that concludes the lesson on derivatives this time.